to Naval Architecture and Marine Engineering with Yogesh Bahadur. In the first segment, we had laid out 10 objectives for this series of modules, or this series of lectures. These are general lectures where you don't have to do anything, you just have to listen. And we are basically interacting on how best we can find the passion and the interest in the studies and courses that we are studying, and also to revive what we have studied in our college times, in our institutes, and what we have learned at work, in our careers over the time, and how we can all get together, interact, and share this vast knowledge which each of us has. The wealth of knowledge is the wealth that we really carry in life, and we want to utilize these corona times, the slack times as people are saying, where you don't need to just pass around jokes and information on COVID-19. There is plenty of it out there, but also utilize this time to do something productive which will help each other and which will help the community at large. So in this section of, that is the module 2, we are going to talk about water. And water in its essence is, water is what we drink. 3/4 of the world is supposed to be having water. 3/4 of our own body is having water. And water it is that we run our ships on. Water it is that drives power through turbines. Water it is which creates the enormous pressure through which huge dams and reservoirs are created for storing the water, for transporting this water to our homes for drinking and for our use, and also utilizing it for agriculture, for irrigation, and to drive huge hydropower turbines that give power. But here today, we are going to be talking about water as we have on the ships and around the ships. Around the ships, we know that the ship is floating on the water. While it's on the port, we are loading the ships, and we are seeing how deep the ship is going with each and every container or the shipment of cargo that we load, and how its draft varies, and the varying of this draft is due to the shape of the ship, the size of the ship, the weight of the ship, of the bare ship itself. And that brings us to the study of what we call hydrostatics and hydrodynamics. And then inside the ship, we have this huge spaghetti of pipelines, the 10s and 15 of the tens of systems, the firefighting system, the bilge and ballast system, the fuel system, the lubricating oil system, the boiler systems, the exhaust systems, the engine operational systems, and all the mechanics, electronics, and electricals that go along with it. But what is carrying the water and the fluids is the pipe and the piping systems. And piping systems we study in the field of fluid dynamics. And so we are going to today talk about what are all these different divisions of study of water and fluids. And water, as we know, derives from the Latin word hydro, and it is from hydro that all these water sciences, be it hydraulics, be it hydrostatics, hydrodynamics, and hydrology, all these fields are deriving, and each of these becomes a course and career path for people who have studied, who have some knowledge about how water behaves inside inside the pipes, and on land you can say the river streams, the canals, the huge pipes that carry oil from one country to the other. So once we have a basic idea how this is happening, and how that little knowledge of those 12 odd chapters of your fluid mechanics books, how they're going to translate into accumulating and enhancing the knowledge that we have from college, and a continuous process of study it is, which gives meaning to whatever we do in life. In sharing all this, we are enriching ourselves in a way that the younger people will be able to benefit from these things. I hope you're all safe from coronavirus. You're maintaining social distancing, the guidelines and various advisory coming from the government and the health authorities. Stay safe. I've received some feedback on the module 1, and we'll try to incorporate the feedback as we go along. And so more of you, please write to me. Now, engineering is such a wide subject that we are bound to have many different perspectives. And as we go along in our career, we are becoming part of many different perspectives, many different fields of work. And naturally, whatever, we cannot all be thinking in the same manner. Took some time to visit some of the course books that we had, and I realized that many of the course books are still being used. And also I did some finding out the way the faculties in various institutes are going about. But when I was preparing for this session, I realized that there was very little I could recall on how these things are different from each other, or what do they have in common. There were a lot of things which were common between them, and there's a lot that we can learn from one division to the other. That means if we have learned the principles of hydraulics, that is basically fluid mechanics and anything to do with flow of fluids inside pipes, inside channels, and this, we can translate that into hydrostatics, which is the study of water at rest, and water-bound bodies which are carrying water which is not in motion. And hydrodynamics is about bodies which are there in relation to water, but the bodies are moving, or the water is moving around the body, and that's hydrodynamics. Hydrology is little more about the properties of water and how the water falls as rainfall and how it spreads around, and like in the ocean, what is the quality of water as we move from one to the other. You must be doing all those ship construction problems where they say that the ship is going from water which has got more silt in it, and as it goes to more clear water and then to seawater, how going from one density of water to another density of water is going to give a change in the draft, even though we are carrying the same amount of cargo. So hydrology is also more related to the oceanic sciences, that is all the constituents of the water, also the sciences that we do to study lakes and rivers. Hydrology has contributed to study of algae and generation of methane gas and other gases from still water, which is stagnant in drains, and from that we have extracted gases like methane gas, and that we are using as biomass and biogas fuels. So these are all these various ways we see the behavior of fluids. What you must have seen is that more and more we are having automation, be it our power plants, be it our ships. We are going for unmanned ships now, and we have unmanned engine rooms. The number of people is reducing. There are more functions which are being handled by engineers in the design than engineers in actual maintenance. That is going to bring about a natural change in the way we foresee our careers in the future. Who knows, that it may not be just marine engineers. We may also have some people from maybe NASA and DRDO, or people who are into the space and and the research about the climate and energy, who will also be sailing on the ships. So, do we get left behind? And this today is going to be more of a discussion into strengthening our knowledge of some of the essential elements of hydraulics, hydrostatics, hydrodynamics. Maybe hydrology we can leave away because that's not coming directly into our purview. Then we are in a position to be a lot better engineers in competition with the engineers elsewhere. And as we go into other kinds of work, this knowledge is going to surely stand by us.